At the forefront of our solar system lies Mercury, a small, lifeless planet shrouded in mystery and curiosity. At first glance, it seems insignificant, but recent NASA research has revealed surprising findings about this world that no one expected. The discoveries, which include data from the James Webb Space Telescope, have sparked controversy in the scientific community. Many suggest the possibility of the existence of extraterrestrial life forms hidden on Mercury. Amidst the chaotic revelations and bizarre conspiracy theories, a new plan emerges within the scientific community, a master plan to unravel Mercury's dark secrets once and for all. What incredible secrets have scientists uncovered about Mercury, and what revolutionary plan does the scientific community have for this mysterious galactic neighbor? Throughout our solar system, rather than seeming like a set of planets spinning on a merry-go-round, each of the 8 planets that make up this enigmatic ring system has fascinating characteristics of its own. Although planets such as Jupiter or Mars have gained attention because of their staggering importance, there is another intriguing planetary body that seems to get lost in the crowd: Mercury. This planet ranks first on the list of planets in order of closeness to the Sun. Its distance from the Sun is only 58 million kilometers, compared to Earth's 150 million kilometers. Mercury is considerably smaller than Earth, with a diameter of only 3,000 kilometers. This characteristic, together with its orbit close to the Sun, gives it the title of the planet that completes its orbits the fastest. With a speed of 47 kilometers per second, Mercury completes a full circle around the Sun in only 59 days. Therefore, a year on Mercury is equivalent to 88 Earth days, approximately 3 months. These peculiarities, such as its small size and rapid speed, are some of the fascinating characteristics of this planet, which might even seem habitable. Despite this, Mercury has long been an object of intrigue for the scientific community, although, surprisingly, it has not captured the same attention as its cosmic neighbors. Observations of Mercury date back to 275 BC, and astronomers such as Giovanni Zuppi in 1639 also conducted studies of this planet. However, the data obtained in those early days lacked the necessary quality, as investigations were carried out with poor scientific equipment and low-quality telescopes. It was not until the 1960s that tangible data about Mercury were obtained, thanks to NASA's efforts. A few years ago, NASA revealed to the public the first real images of Mercury, showing the planet as a celestial wonder of beauty and complexity. However, these images were not easily obtained. Despite years of planning and effort devoted to exploring Mercury, scientists were only able to get a glimpse of it. Mercury's proximity to the Sun makes detailed observations difficult compared to other planets. The Sun's intense rays and bright light pose a threat to optical instruments, such as telescopes, when focused on Mercury for long periods. Scientists must limit the time spent observing the tiny planet to just a few minutes to avoid damage to equipment. Even the James Webb Space Telescope cannot be directed toward Mercury because of its proximity to the Sun. It is puzzling how this relatively small planet is more difficult to study than more distant planets, all because of the Sun's temperature and gravitational pull. Sending a probe to Mercury represents more of a suicide mission than a stellar exploration, as the probe must adapt to extreme conditions of temperature, atmosphere, and gravity. Otherwise, it runs the risk of being destroyed. Mercury orbits the Sun at a dizzying 30 miles per second, making it the fastest planet in our solar system. This speed poses additional challenges for spacecraft attempting to study or land on its surface. So far, only 2 missions have targeted Mercury: Mariner 10, launched on November 3, 1973, and Messenger, launched on August 3, 2004, both from NASA. These probes are the main sources of information about Mercury. Mariner 10 made 3 flybys, revealing a surface full of craters and ridges, as well as illuminating its magnetic field. Equipped with 2 telescope spectrometers and a magnetometer, NASA aimed to obtain as much data as possible from this visit. The probe found its way to Mercury by using Venus gravity to slowly approach the planet. Scientists were amazed to observe Mercury's chaotic surface, riddled with craters and ridges much like our own Moon. The images sent back by the Mariner probe were shocking, as Mercury looked nothing like what experts had anticipated. In addition to revealing the planet's topography, the spacecraft also detected a weak magnetic field and an unusually large core. During its flybys, Mariner 10 captured more than 2,700 images of Mercury, providing scientists with an unprecedented view of this fascinating world. The final flyby occurred in March 1975, after which the probe stopped transmitting signals to Earth due to the depletion of its fuel supply. 30 years later, NASA's Messenger mission blasted off to Mercury, offering a unique opportunity to study the planet in detail. Unlike its predecessor, Messenger not only performed flybys but also managed to orbit the planet, allowing for more in-depth and interesting data to be collected. The Messenger probe was equipped with instruments to study the atmosphere, chemical composition, magnetic field, and geological history of the planet. During its 3 orbits around Mercury, it took nearly 200,000 unique pictures, including images of both the daylight and dark sides of the planet. By digging deeper into these images and comparing them with data collected by the spacecraft's instruments, NASA discovered that Mercury had unusually high concentrations of calcium and magnesium on its night side. In addition, the planet's magnetic field appeared to be strangely distorted, being the strongest and most intense in the northern regions. The enigma of Mercury's peculiar magnetic field puzzled scientists, who conducted a thorough investigation to unravel the secret behind this anomaly. When the secrets were finally revealed, they sent shockwaves through the scientific community. Mercury's unusual magnetic field is due to the way the planet formed in its core. For example, in the case of Earth, reactions in its core generate magnetic field. The innermost parts of Earth's core contain liquid iron, but toward the outside, this iron gradually solidifies. This continuous solidification of iron in Earth's core is what causes its magnetic field. As the liquid iron cools and crystallizes to form solid iron, it interacts with the surrounding liquid iron while Earth rotates on its axis, thus generating a magnetic field that extends out into space. However, the way Mercury's magnetic field works is completely different. Recent research led by Howe of the University of California, Los Angeles, revealed that iron transitions from liquid to solid at the outermost boundary of Mercury's core, in contrast to Earth, where this transition occurs at the inner boundary of the core. This discovery left scientists amazed, indicating that our understanding of how both Earth and Mercury function as real planets with iron cores presents a unique challenge.